Okay, so today we are going to do, listen up, we are going to do the last notes of the year. Okay, we are doing our last notes of this year.
Second one for this very beautiful moment.
That's right, last notes of 2014. So we are on chapter...
Oh, you teased us.
I didn't tease you, these are the last notes of the year.
I thought you meant the school year.
No. So, for chapter 4.9, okay, if you notice in your book, we are skipping 4.8. Okay, we are skipping 4.8. We should all be writing these down. Chapter 4.9 are going to be qualitative graphs. Okay, we're going to do something called qualitative graphs. Okay, guys. Let's write this down. Yes.
I'm trying.
I'm sorry. I hope so. I'm hoping so, yeah. Okay, so first thing we're going to look at, okay, is for example number 1. I'm going to tell you the graph, okay, the graph shows the number of people at a restaurant. So we're going to draw a graph, and it shows the number of people at a restaurant during the morning and afternoon. Okay, the graph, and we're going to show you one. Shows the number of people at a restaurant during the morning and afternoon. What I want you to do is we're going to ask you to describe. So most of what you're doing today is actually going to be in words. Okay, so describe the change over time. Describe the change in number of people over time. Describe the change in the number of people over time. So we're going to draw a graph. We're only going to draw the positive part because it doesn't make sense to have any negative people or negative time. Okay, so in the on the bottom is going to be time, and on the side is our number of people. Okay, so this is our number of people. So when it opens, there's a bunch of people, and then it stays kind of consistent, and then it goes way down, and it stays consistent, and then it goes way up. That's all I'm giving you. Say again?
That's confusing.
Not too bad.
That's like Starbucks.
We're getting there. Hold on.
It's like how Starbucks. Confusing. No. Never mind.
Why do people wait outside of Starbucks when it's not even open?
I don't know. Okay, so do we all have this written down? Yes, question.
I just want to know, you know how you have a coffee maker over there? Can you make a coffee?
No. Okay, so for this, so basically, I'm not giving you any numbers here. I just want you to tell me, what do you think this graph means? And there are not necessarily right and wrong answers. Okay? Tell me, what do you think this graph means? If I told you that the graph shows the number of people at a restaurant during the morning and the afternoon, tell me about the change in the number of people over time.
More people come in the afternoon.
Okay, more people come in the afternoon. What else can you tell me? And you can't tell me just about the end. So, Darian's telling me, yeah, at the end, towards lunch, there's more people coming. But what about over here? What does this show?
It kind of goes up and then it drops. It goes boom.
Okay, so we know that it drops. Okay, so I'm just gonna write on here like what's happening. Okay, so this is definitely means it's increasing. Okay, we say this is where it drops. What's happening during this time right here? If it's flat, that means it's doing what? It's constant. Okay, this is where it's constant. And here we're talking about number of people. So this could be something like speed. Okay, but we're not talking about the speed. This means that there's a constant number of people. What is it doing right here?
It's rising up.
It's increasing, okay, or rising. What's it doing right here?
It's like.
It's consistent or it's staying the same. So we need to, and you can write this however you'd like to, okay? I would say that, so we're going to write a situation. So I would say when it opens, the number of people, should we say, is this like steadily increasing or is it, how would you say that, what would you describe what it happens right when it opens? It rises, okay? Would you say that it's like fairly consistent when it rises? Okay, so when it opens, the number of people increases. During breakfast, what do you think is happening here? So like this is maybe during like the breakfast time. During breakfast time, what would you say had happened, Sarah? During breakfast time, it stays the same or it's constant. Okay, during breakfast time, it stays the same. What would you say after breakfast time?
It drops.
What happens then? After breakfast, so there is definitely going to be some writing involved here. After breakfast, the number of people decreases. After breakfast, the number of people decreases. So it drops off. Then what happens?
Then it rises.
Okay, well, it stays the same for a little bit here. So it drops. After breakfast, the number of people decreases, then stays the same, or drops off. Or, sorry, the number of people decreases, then it stays consistent, okay? So then stays the same. Then what happens once it's getting closer and closer to lunch? Finally, the number of people increases during lunch. Finally, the number of people increases during lunch. You don't have to write down the exact same thing. You just need to describe what is happening here. Okay? So you need to be able to describe what's happening. And your scenario might be different. Okay? You can make it whatever you'd like it to be. Everyone should be writing these down. So I'm a little confused why there's some people that don't have pencils in their hands. That's not a good thing.
So we're just basically describing the
That's it. Yep. You're just describing. Okay? Now, the ones that you're not describing, okay, listen. You may also have to draw a graph. Okay? So this is describe. Okay? This is when we are describing. Yeah. Okay, so the first part is going to be just describe a graph. The next portion is going to talk about where I'm going to give you a scenario and you need to draw a graph. Okay, so I'm going to give you a scenario.
Like the opposite.
Yeah, so I'm going to give you the words and you're going to draw a picture.
You suck. You don't have to do your nose. Let me see your nose.
Okay, are we all almost done here?
No.
Okay, well let's try to hurry it up here. Okay, I only have one more and then we're gonna only have one more for notes here. Yep. Okay. Are we ready? Okay, for example number 2. Okay, so this is describing, this is drawing your own graph. Okay, people, come on. Ariana, write these down. Describe. So this is where you're describing a graph. This is where you're going to draw a graph based on what's going on. Ladies, please. Okay, so we're going to say Mrs. Kuhn is playing fetch with her dog.
Oh, I thought you were fetching.
No, I am not fetching. Okay, Mrs. Kuhn is playing fetch with my dog. His name is Sparky. Okay, it really is. That's my dog's name, yeah.
That's like something.
So, Mrs. Kuhn is playing fetch with Sparky. If you don't...
like the movie. So the dog, his name is Spark.
I don't know. Okay, so I'm playing fetch with my dog, Sparky. Okay? As I throws the ball, away from him, he runs to get it and runs back. He's a good fetcher. Sometimes.
My dad's retarded.
Oh, she's so much rainy.
So, he runs to get it and runs back. I would like you to sketch what's called a qualitative graph about this situation. Qualitative graph. It just means it's not a line graph. It's a qualitative graph means it's a graph, a picture about a situation.
Also, you can draw a stick figure.
No. It's still a graph, but it's about a situation. Okay, so first thing you're going to do is you're going to make this is always going to be positive. Okay, so what are my 2 things here that are going to be on the sides? Sparky is not going to be on my
How
graph.
far you throw the ball and
Okay,
or no?
is it about how far? Is it how far I throw the ball? So here it says, I'm playing fetch with Sparky. As I throw the ball away from him, he runs to get it and runs back. Sketch a qualitative graph about this. So what are the 2 things that are happening here? I'm throwing the ball, he's running. Well, what can I graph? Can I graph how far he's running?
No.
I can graph how far he's running. Okay, what you're trying to graph here is you're going to graph the time. So would time be like how far or how long I've been throwing the ball? Would that be on the bottom or on the side, do you think? Probably the bottom. We almost always put time on the bottom. Okay, so we're going to put time elapsed. So that, does anyone know what does the word elapsed mean?
Nope.
Time just means that has gone by. Okay, so time elapsed is time that's gone by. Okay, and what we're going to graph here is the distance. Distance away. Okay, so if I'm here, okay, say like I am here, and if I throw the ball and he brings it back, how would you say you would graph that? Is he getting farther away from me?
Yeah.
Right? So we're going to say he goes far away. But then what happens?
He comes back.
He runs back. So where would that go?
Down.
Right back. Does it go straight down or is it coming back this way? Is it like a V shape or is it go straight down?
straight down.
Okay, well let's think about this. Okay, hold on. hold on. Let's think about
He has
this.
to go get it. And then
He has to turn around. So can he come straight back?
No, he has to turn.
Well, he has to turn around, but doesn't it take a little bit for him to come back?
Exactly.
So we can't be immediately here and then immediately back, right? So it can't be a straight line because that's an immediate thing. Or it can be a straight line, but it can't be straight down. So there has to be a little bit of slope. So basically, however far he ran away, he's going to run back. And it's going to take him about the same time. Okay? So it's not going to be, he can't go straight up and straight down all in the same time. Okay, he can't immediately run away and then come back. So you can't draw just a straight down line because that would mean he is like,
Speed.
a long ways away and then he's immediately back. That doesn't work, okay? There's some time that's gone by. So it can't go like this. Now, what happens when I throw it again?
He does the same thing.
Is it gonna go the exact same distance?
No.
Maybe, but probably not. Maybe I don't throw it as far. And then what happens?
He comes.
He comes back.
Far. So
Wait, he doesn't go as far?
if you don't throw it that far, he doesn't go that far.
Okay, I see what you're saying. So if I only throw it this far, it might only go to here. But then he comes back. And you're going to make these about the same, what is it called when it's going up and over?
No.
The slope. Right. So that means if it takes him about this long to get there, it's going to take him about the same amount to go back. So I don't want your graph to be just straight back. Okay, it doesn't work that way. Now, maybe say I throw it like really far, or my husband throws it, and he's better at throwing a ball than me. So he throws it farther, then what happens?
It goes farther and then.
But he comes back. Okay? You can make this as many times as you want. So you could throw it 10 times. You could have 10 little jumps. My dog, though, I'm going to tell you for sure, kind of lazy. He's kind of slow. So I'd be lucky if I threw it like 3 times and he brought it back. Then I'd probably throw it again and he would not go anywhere. He would just stare at me and lay down. Okay? So my graph could be really short. Okay? You could make a graph about your dog if you have a dog. Okay? If you have a dog and he really likes to fetch, you could have 50 little jump up and down and scare. Okay?
He picks up the ball and just.
Awesome.
He's fat, then he's not going to do it.
Okay, thank you for sharing about Boss, the dog. Okay, so you are going to be drawing situations about, listen, you're going to be drawing quantitative graphs and you're going to be interpreting quantitative graphs. Okay, that is what we're working on today. So homework is technically on page 351. You are doing numbers 1 through 4 and 9 through 14. Okay? Listen, I am giving you guys some time to